Thanks to those that have joined us already. We're just going to give it another minute or two to let a few more people come in and join the session, and then we'll make a start. So if you can hang on for a minute or two, then we'll make a start on the presentation. Thanks. Okay, well, let's make a start. So welcome everyone to the final In Detail webinar celebrating our RIAS Special Category Award winners 2025. I'm Zoe Black, I'm Head of Practice at RIAS, and our awards this year were judged by Jesam Al-Jawad, Anne Nisbet, Caroline Greer and Craig Hamilton, who shortlisted 21 buildings, 11 winners and a further 7 special award winners. So this webinar will be recorded and will be available shortly afterwards on YouTube, and you can catch up with our other first 3 sessions already on YouTube this way, if you like. So this week, we're joined by Anne-Marie from Archetype, as well as our clients, Robert and Chris from Perth and Kinross Council, who'll be giving us an insight into Riverside Primary, and I'll introduce them a bit more fully later on. Riverside Primary School stands proud as the first certified passive house school in Scotland and demonstrates how impactful well-designed healthy living environments can be. So the school was the winner of the RIAS and Luths Services Sustainability Award, as well as the RIAS and the Survey Association Client of the Year Award. And we're delighted to have representatives from both of these organisations, Gia and Rachel, with us today. So a short reminder that the session will be recorded and shared afterwards, and there is a Q&A button at the bottom of your screen, so please feel free to use this and submit any queries throughout the session, and we'll come to the questions at the end. We'll move through the questions then. So I'm just going to introduce first the first of our sponsors from Luths. I'm just going to hand you over to Gia for a quick chat on Luths Services sponsorship with the award and their support of RIAS. So thank you, Gia, if you'd like to tell us a bit about Luths.
Thanks for the introduction. I'm standing in for Dan today, so he's our founder at Luths. I work closely with Dan and the wider team across operations, supporting project delivery and marketing. At Luths, we're really passionate about sustainability, sustainable design, making it more accurate, accessible, and kind of impactful. I've been working with them for over a year now. I had the pleasure of meeting Marie at the awards and then later again at a collaborative event at the engine shed. And it's my favorite part of the job is meeting these people, the professionals who genuinely are passionate about the impact on the environment, but kind of shared purpose of working towards sustainability, like projects like Riverside. So congratulations to the whole team involved with that project. It's a really inspiring achievement. And yeah, we're really proud to celebrate it with you. The next slide is just, again, an introduction to this, what we do.
Okay, That's great. Thank you very much, Gia, for that short introduction. That's great. And our other sponsor is the Survey Association. And I'm just going to hand over to Rachel for a quick chat on the Survey Association sponsorship, the Client of the Year Award, and their support of RIAS. So I think, Rachel, I'll just let you do a quick introduction and you can tell us a bit about yourself and why you sponsored the award.
Lovely, thank you, Zoe, and thank you for the invite today as well. It's we've been working. So the Survey Association is the UK trade body for land survey professionals in the UK. Membership is by company, and membership is also quite hard for surveyors to attain. They are quite rigorously assessed, and architects form a large chunk of their client base. So for us as the Survey Association, working with RIAS over the last 5 years is really important to us in terms of collaboration, understanding your stresses and strains and challenges, and then trying to work together to make sure that you can kind of maybe understand a little bit more about where survey professionals are coming from and how much they can impact an architectural project. It's been absolutely inspirational working with you for the last 5 years, and I think the awards is definitely one of my favourite events that we go to. My involvement with TSA stretches over 27 years, and we're always looking to have that back and forth with other organisations, which I think is really key to kind of just broadening out and just collaboration. It really does work. So this particular project was really inspirational actually, and from a TSA point of view, we're heavily into education skills, the next generation. So this ticked many of our boxes, and I'm just really looking forward to hearing about it in more detail. Thank you.
Right, thanks very much, Rachel, and thanks both again for your support. Right, so now we're going to move on to the main part of today's session, which you're here for. And to present Riverside Primary, we've got representative from Archetype and Perth and Kinross Council, as we mentioned. So we've got Chris Anton, who's the lead officer for energy and engineering at Perth and Kinross Council, and Robert Meiklejohn's a chartered architect working as a project manager at Perth and Kinross Council from our client side. And finally, we've got Anne-Marie from Archetype, who'll be leading today's presentation. And Anne-Marie's Associate Director and Passive House designer at Archetype, joining the practice in 2016. In 2019, she opened the Archetype Edinburgh studio with Managing Director John Hines. And this year she became a board member at Best, supporting innovation and quality in construction. So thanks very much, Anne-Marie, Robert and Chris, for joining us today. We'll just a reminder to put any questions in the Q&A box, and over to you.
Okay, great. Thank you, Zoe, and to Gia and Rachel for the sponsorship, and great to be here today. And without further ado, I'll get moving. I will just say that I'm on a live site at the moment, so I'm hoping no one comes into the meeting which has been booked for us, but yes, bear with me if that does happen. So yes, after all the introductions, and everyone can see my screen okay, I'll just bring you through a more detailed narrative of Riverside and hopefully a little bit of under the skin thinking and process behind the delivery of the project. So Archetype's practice has been around for about 40 years now, and over the last 15 years specifically, we've supported and utilised Passive House as a methodology for building delivery, primarily as a response to the climate emergency, but also in relation to the increasing quality issues that we're finding across the construction industry. And Passive House is a building standard that can be applied to basically any building typology. So there's a kind of scale and range there as an example of projects that can be delivered to the Passive House standard. And in a reflection from our own 40-year anniversary this year, we've looked at projects over time that we've delivered, and there's a gradual downward trajectory. So we really are trying to focus on increasing efficiency and decreasing the energy use intensity in particular of our buildings, both through material selection and through energy consumption and performance. And a couple of examples of those existing built projects, which we continue to monitor within their use. The first Passive House timber CLT secondary school in London, Harris Academy. One of the first net zero in operation schools, also in London Borough, Sutton, Hackbridge Primary School, also a timber frame school, a very low embodied carbon school, and much closer to home in Scotland. So Maybury Primary School finished just last year, and Curry Community High School, which includes a kind of leisure facilities and swimming pool as well, which is just finishing very soon. So yes, just a bit of a round the world trip in some of our previous projects. And finally, what's really interesting to us and what I'm personally very nosy about is actually how buildings perform after practical completion and how the users engage with those. And the Enterprise Centre that we've completed in 2015 for the University of East Anglia is a great example of that, where the energy performance of the project, the local use of materials and the other elements of that project have lent themselves very well to performance over the last 10 years. And in 2015, we were delivering on the net zero carbon building standard targets that have been set for 2020. So 35 years in advance, this building was performing to the future aspirational net zero standards that the UK industry has set. So why is Passive House so good for school design? Well, as a typology, whilst they're a very enjoyable space and very exciting emotive typology to design, they also come with many environmental challenges and conditions. And I'm just giving you an overview of some of them here. So, you know, we move from a building that has quite variable occupancy. Depending on the location, we're dealing with external noise and pollution sources. Typically, we find a lot of schools are near quite busy roads and carriageways, particularly new build schools. And then we have internal comfort challenges and different conflicts around that in terms of the ventilation rates that we require in buildings, generally the new BB 101 regulations, and the potential energy consumption that we don't need to use to achieve those rates in a good way. Overheating risk, the indoor pollution sources that we have, of course, and the kind of conflict around windows and opening and kind of operating buildings within an education context, safety, safeguarding, all of those things. And they have many impacts to do with thermal comfort, increased energy use, and poor indoor air quality. And Passive House has a multitude of benefits that mitigate and eliminate much of those issues, and as evidenced by Riverside and other projects. So this is a school building in Scotland, a secondary school that we monitored back in 2018 to just before COVID, where we can see this Monday to Friday in February 2019, where there was quite unhealthy levels of CO2 appearing in all of the monitored classrooms. And this is very typical of a recently completed school. This school was finished in 2017. It was lauded as a low carbon school by a different design team. But we were getting comfort and indoor air quality issues, and the local authority sought to monitor and try and improve the situation. By contrast, Passive House brings much more controlled indoor air quality. There's much more benefit attached to the MVHR ventilation approach that we have in Passive House buildings. And you can see here, this is a study from 2014, one of the very first primary school buildings in the UK that was Passive House, Wolverhampton Primary School, where we actually are already complying with the current 2018 BB 101 ventilation regulations by virtue of it just being a Passive House design. So again, several years before those new regulations came into effect. And most recently, we've been carrying out research with one of our colleagues, Chrissa and UCL, looking at the nature of volatile organic compounds and other materials within air quality in Passive House schools in particular. And when compared to the business case across 4 of our monitored schools over the 6-year period, a bio-based Passive House project has 60% less hazardous exposure to indoor volatile organic compounds than a business as usual non-bio-based school. So there's some fairly compelling research findings that we're hoping to publish over the next couple of months out of that particular research, which is really compelling. And then finally, we've been, since we've been involved in Scotland, we were working with the Scottish Futures Trust to influence maybe how that policy and agenda around quality can be moved forward. And that has occurred through the introduction of the Learning Estate Investment Programme, having targeted energy bands and having other performance metrics tied to an outcomes-based funding model for those who might not be familiar on the Zoom call, where schools will be paid for over a 25-year period on the basis that the local authority is reporting regularly to the Scottish Futures Trust on achieving and attaining that energy target. And we'll see where when Chris chats to us later on about how that's been impacted and how that's been rolled out on Riverside. So in relation to that LEAP metric, the target EUI for your 100% funding over a 25-year period is 67 to 83 kilowatts per metre squared per year. And the final year 1 results for Riverside were around 45 kilowatts. And the year 2 results are looking around the 35 kilowatt hours per metre squared per year marker. So we have the client, Perth and Kinross Council, to credit for that great change in performance between year 1 and 2. And again, Passive House gives you that really good low energy consumption, low energy demand. So it facilitates easily achieving those targets for guaranteeing that funding going forward. So bringing you right back to the start of Riverside and where we were with the early design development and general briefing on the project. So this is a slide I tend to forget to put in, and I have to, of course, credit the rest of the team that were involved in this project, including Warm as a Passive House certifier. And we delivered it via Hubby Central, via hub procurement for Perth and Kinross Council. And quite an ambitious design philosophy. So in 2019, Perth and Kinross Council were the first council in Scotland to declare a climate emergency. And within the November of that year, they were setting a brief for their first Passive House project, which was Riverside. And they've set briefs for Passive House projects since then as well. As well as the energy requirement on the project, there was, of course, other philosophy around the design that had to be taken into account as well in relation to health and well-being and other ambitious pedagogical requirements that the project needed to focus on, and local supply chain and a couple of other things. And we sought to try and take that into the project through the Passive House methodology, which can facilitate very nicely these elements for design and spatial quality and connection to the outdoors across the design intent of the project. An important part of the start of the project for us was that we got to really engage collaboratively with Robertson and Perth and Kinross Council as the main education client. So we sat down and worked together through the ACRs to reflect better a Passive House project being delivered because the current ACRs or authority construction requirements didn't quite reflect the targets that the client was going for. So again, that collaborative open approach from the contractor as well to work with the council. And that the proposals were developed alongside the contractor and the client very holistically from the beginning. So I know sometimes there's a feeling that working with a contractor very early doors can be very limiting. And yes, there has been elements of VE on Riverside, but we overall feel, of course, that we've been able to hang on to as much of that design quality and integrity that we could. And also Archetype was employed as the Passive House designer and the architect. So the kind of integrated hat of wearing both the energy modelling requirements as well as the architectural. The existing school site was chosen where North Muirton Primary School was currently. And Robert, please do jump in if you want to give any other context to this. And there were several studies done initially by others looking at a feasibility of fitting another school on the site and having a tandem build going on. And I guess the critical community move here by the council was to bring two school communities together on a larger site that was better consolidated just outside the city centre, that freed up Balhoosie Primary School site inside the city centre for housing and community need, which again, from a kind of strategic sustainability objective, I think is quite significant from the council.
Yeah, I would just add, Amber, it's a really good site as well. I think that's
very optimized, wasn't it? Yeah,
and it's a large site, and so it's quite easy to choose in terms of providing the school for Balhoosie and here. It was the perfect option to do.
And I think the original school, Robert, when it was built in the 1970s, would have been, it was an open plan school, very typical of its time. And just the school was oversubscribed, and the open plan nature just didn't lend itself to the kind of learning requirements that were there in the community either.
The school was finished. It done its a good shift, but it was over, and we were also moving the two schools together, so the other site at Balhoosie wasn't enough space basically as well. So it was I think it's for the project, it was we've got a nice flat site with a good space to do a tandem build, and that from the outset that really did help. And as you touched on, we had actually looked previously and did this couple of studies with another architect, early doors, stage 0 stuff, which quickly were changed actually when we moved to Passive House.
Mm-hmm. Yes, because there's several challenges on the site, I guess, with the kind of single-story 1970s school, the need for that to continue to be used, And we then, of course, took that forward through the hub process and continue that feasibility assessment on the site in terms of placement and massing, also paying heed to wanting a bit more optimization for solar gain for passive house purposes. You know, could we orientate the massing as south as possible to have that north-south classroom relationship? And also it felt like giving more of a civic presence to the south of the site could become a catalyst really for more development within the local area. So there's kind of a series of little community shops and services to the south of the site. There's a bus terminus, and there's kind of a natural gathering of a bit of community need in that area. And to kind of focus the building down that end of the site really allowed us to work on that from a kind of beyond the site perspective as well.
Yeah, it's given a great playground as well for the kids.
To the north,
fantastic.
Yes. Yeah. And kind of more structured series of spaces as well. And again, I think this final massing then also allowed for the early years and early learning, the nursery space and ASN to all have dedicated play spaces around the building, directly adjacent to their immediate internal spaces as well. So at the beginning of the project, we were working through pedagogy with the council as well. So there was several examples of schools we visited of pedagogies they felt worked really well, from Ailith to Perth Kinross Primary School and others. And the debate was around the nature of how we move forward with open plan learning, digitalization, the growing variation of needs within students. So there's a lot of work done on that in relation to how we provide a suitable amount of spaces with that flexibility. So in the end, a kind of series of clearly defined open plan classrooms and closed plan, but accessible visually to both inside space and outside space classrooms, and a series of smaller spaces were designed into the kind of quite simple form as part of the brief. And also the kind of internal street space allowed for a kind of informal learning and breakout around those classroom areas as well. So just moving back to kind of where we were at kind of hub stage 1, so the end of RIBA stage 2, a little indicative sketch where you can see from the kind of final building there were some tweaks again to roof elements and the sedum roof on the nursery. Again, that roof got covered by photovoltaic panels, and if anyone's done a sedum roof or green roof with photovoltaic panels, you'll realise from a fire point of view, you end up with very little sedum or green roof underneath the PVs themselves. So a decision was made to bring that back to a membrane roof as well. But we kept the form factor at around 2.1. So again, form factor is quite important for passive house efficiency. And due to the small scale and nature of the project, we were able to kind of allow the form to remain quite simple. So kept the single story nursery to the south, the block and spine of the main education spaces in the middle, facing north and south as well. And the kitchen and the hall and the taller elements of the building more to the northwest on the site. So we have a 500 pupil 2-stream school here with about 668 staff and students on the site as well. And yeah, the dedicated ASN and a 52-week operating nursery, so outside of the normal school hours also. So just some of the CGIs that were developed for the project as well. So when that achieved planning, so we're talking about 2021, and we moved straight into hub stage 2 and the kind of working drawing side of the project with Robertson Construction. And from hub stage 1 to hub stage 2, the project changed from CLT to steel frame as part of a value engineering exercise. And again, there was no context for passive house steel frame schools in the UK at the time this was done. So there's a lot of exploring, collaboration and kind of risk assessment of how this may move forward on site. And this is just giving you an indication here of where we feel fabric and airtightness complexity might sit with different constructions. So of course, you know, any construction can be made airtight, but there's an element of complexity when you start introducing insulation, vapor tightness, airtightness, and weathering requirements into that. And whilst I'd love another hour to tell you all about our findings from that, I hope you do look up this paper that we did as part of the Passive House Trust guidance documents, which leans heavily on our experience from Riverside and also Curry Community School and a couple of other schools across the UK as well. We worked collaboratively in a working group to bring those findings together. And just some examples, I guess, from the site to do with construction. These images are just showing the kind of a cement board that sits outside the primary steel frame with Wrap-Tite as the primary air tightness layer on the outside. And there was insulation in the SFS infill zone within that primary steel, but also a kind of T-cozy of external rock wall geoslab insulation around the outside to limit any thermal bridging. And you can see the way the door frame is kind of jutted out from the cement board line. That's for the insulation to butt up against it as consistently as possible. And Robertson were really great at QR coding all of their penetrations. So I think there was something like 115 penetrations on the project that all had a QR code that all got really regularly signed off as the contractors moved around the project. But those topics on the left-hand side are all covered in the guidance document from the Passive House Trust paper. And just again, some examples of when we talk about Passive House, what we are looking for is good quality installation through the construction process. And we can see here some very good examples and improved examples, and some less so, and developed details that are in development. So again, plenty of examples of these in more detail in the Passive House Trust paper. So what does that mean in terms of the design intent? So by virtue of delivering steel frame, is that going to affect the requirement on how we specified materials internally? So the recycled wood wool, lino, flooring where we could, again, try to keep low VOC materials based on the research that we've been carrying out as well. And this is the example of the street and the internal view of that street then within the steel frame. So before the roof lights are broken out. And I think we have done a good deal to hang on to the integrity of that initial image or initial intent set at the design stages, given the VE. And again, in this case, we changed the clear story to a series of to a series of fixed roof lights to give light to that first floor internal street and series of breakout spaces. This is an overview of the site as it was developing. So we can see the air tightness membrane, quite interesting. Some of the other tier 1 contractors across Scotland thought that all air tightness for Passive House projects was a red membrane, and they were quite worried that their particular project didn't have the red membrane on it. So I thought that was quite funny, actually, because it is, it's very, very legible, and it's very identifiable. And I think that's really a positive thing for contractors to work with. So we can see the frames going in for the windows. The CalZip roof is on in this image as well. And yeah, there's a kind of bringing together of the air tightness and window detailing. Just to touch a little bit on M&E, so something we don't tend to consider too much, I guess, in one sense as architects. The M&E guys come in afterwards and design around our spatial requirements and the brief requirements. And in Passive House, we really need to work together to ensure that M&E is done really collaboratively, and that they're almost designing as much as we are in terms of making sure we place plant in the most efficient spaces. So we can see here in the floor plan, items 6 and 7 are key MVHR plant rooms across the building. The air source heat pump array is kept as close to one of those primary plant rooms as possible in the back. And plant room 6 is where the 2 primary MVHRs sit and distribute down through the central corridor. So again, trying to avoid unnecessary distribution losses where we can. And really interestingly, the overall building ventilation rate for this project is 6 litres per second per person. Typically, we'll see for a school anything between 8 and 12 litres per second per person being designed for as a minimum. And we are finding in Passive House, not just Riverside, but other projects, that we're more than achieving indoor air quality requirements of 1,000 parts per million or less with that lower ventilation rate. So, still conserving energy. And Chris can talk a bit more detail about how we further optimize that later on. Another bit of innovation around this project is looking at how the hot water was utilised. So we've utilised instantaneous hot water for all the classrooms, and there's just a storage tank for hot water for the catering kitchen. So we've eliminated all water storage on the project. That means the heat pump is decoupled from hot water creation as well, apart from the kitchen. And there's a great efficiency we've achieved there. When we think about how much hot water is really used in some of these buildings, it's an area we really should monitor to really optimize the design. So Baker Hicks contributed the CIBSE article around hot water. And even though it wasn't a requirement at the time, we've revisited Riverside to look at its carbon impact. So the Learning Investment Programme since have mandated embodied carbon module A targets for projects looking for education estate funding. And the upper level target for that is 600 kilograms CO2 per meter square per year. Riverside's coming just under that. And when we look at the whole life carbon, which takes into the in-use scenario, including the fuel use over that 60-year period, we're looking at under 1,200 kilograms of CO2 per meter squared. So again, there's a whole kind of presentation and investigation we could go into just about the carbon difference between the CLT and the steel frame. And maybe we can get to do that another time. So the really interesting bit for me then is, we've been through that design process and we'll go through some of the kind of lessons learned on the contractor side now as well. But in terms of the building performance evaluation, one of the requirements for funding is that the local authority undertakes building performance monitoring to prove that the building is performing as designed. So that initial period can be 12 to 18 months, with the local authority reporting at the end of year 2 for that first financial drawdown of the outcomes-based funding. And PKC, due to their great energy team, and Chris is here to talk about that in more detail, they're continuing to monitor and optimise the building since, and troubleshoot any issues that are approaching. Again, the user is really important in this. So whilst Passive House and Riverside, it's a very quantitative energy standard, we are also really, keen that we get good qualitative feedback from the users. So that's been really clear with the head teacher and the students since they've moved in, with a number of different quotes. And again, Robert, you might have any other examples since then of how the building has been performing. But overall, it's been really positive. And if we think about the kind of community anxiety about bringing kind of two communities of schools together, merging staff and pupils, overall the building's acted as a kind of a safe space to do that in, and brought everyone together really seamlessly. So I think, we're really happy from a kind of community context that it's done that. I could probably put 20 slides together on these 3 graphics, but we don't have time. So the operational energy of the school, Chris will tell me actually the average school isn't 201 kilowatt hours per meter square per year in the Perth and Kinross region anymore, because he's done a lot of work to bring that down, particularly in the primary school stock. So we can touch on that. So we're looking more at the kind of 116 to 130 for the average use, but that's still a great drop for operational performance for Passive House, for operational energy, on Riverside. The internal temperature range, and so there's lots of feedback. We have monitoring on every room, so we're able to see temperature fluctuations and the kind of increase in temperature if there's been an increase in occupancy, for example. So there's lots more detail on that, but overall the average building temperature has remained quite steady, and that's been through a couple of heat waves as well, which I'll touch on. And of course the indoor air quality and the kind of overall sense of kind of well-being and air, the idea, that kind of sense of fresh air in these buildings, you kind of really have to visit them to believe what I'm saying about them. But there's just a clarity to the air and a very calm learning environment as a result of these 3, particularly temperature and CO2 together. Another slightly nerdy element of post-occupancy is actually looking at where the energy consumption is across the building. So you can see how low the hot water and heating are generally for the building here, in comparison to, say, the kitchen and the plant and small power. So it is quite interesting that our own user behaviour actually significantly contributes to building energy. And we can see that about a quarter of the building's energy consumption is small power. So, unregulated loads like plug-in appliances, smart screens, that kind of thing, which we've itemised through the design process, and the kind of hot water in classrooms. So by nature, just how the monitoring happens, the small power segment of this graph is also the hot water in the classrooms. And future projects, we'd love to be able to separate that out. But in terms of a design, that's something we need to talk to the engineers about at the very beginning. And the other hot water in this is actually the hot water for the kitchen. So as far as I'm aware, this school doesn't do catering for other schools, Robert, does it? It's just its own school. Yeah.
No, just its own.
So yeah, that may go, that would be maybe a bit higher if it was doing a little bit more catering in the area. But and again, yeah, lift, server was another area we're a bit worried about through the design, because of the digitalization and the impact of improved enhanced cables and all of those other things, but relatively small use compared to other areas as well. Something that just in conversation last September with Chris, who's on the call from PKC today, was actually one of the most exciting things I heard about, which was the reduced energy load coming in through the substation. So at that particular point in time in 2024, the building was only using about 30% of its capacity of the substation that had been designed in play. And the narrative of that was really interesting. So we knew as a passive house project, we would not lead the amount of connected load that the engineers were quite nervous about underestimating. So we worked with Robertson and the client to get that down from about 650 kVA to 400 through the design process. That still allowed enough kind of redundancy in it for the engineers to feel comfortable. And there was concern that it's an all-electric school. There's going to be electric vehicle charging. There's electric hot water. You know, this school's going to blow the grid. You know, it's going to be so energy intensive. And of course, the irony is that because it's passive house, it's absolutely not energy intensive. And if anything, it takes pressure off the grid while still providing all of the same services and facilities. So to get down to that end of year one result of having less than 125 kVA being used on the project, again, these are Chris's figures from PKC and not ours, allows the council, and I believe just have gone back, Chris, to reduce the incoming load, and therefore between £5,000 and £7,500 saving just on reducing the standing charge for the school. Never mind any operational savings has been achieved, hasn't it?
Yeah, so the biggest thing, without obviously going into the engineering world too much, when you're designing and you're looking at everything working at maximum capacity, but when you're looking at electrical load, and the big risk is when you're moving to heat pumps and electrical heat and decarbonising the grid, is that there is going to be a huge cost for, you know, new substations being installed. There might not be capacity in the grid. But the good thing about this school, we do our own analysis through the BPE and our further for the next year. And looking at the kind of peak loads, we call them, we've only gone up to about 125 maximum. So we managed to reduce it down from 400 to 199. So looking at the figures today, it actually saved us about £700 to £800 a month just on standing charges because of reducing these. So we went back to SSEN, our supplier, and reduced them. So that's something that we want to feed in. We spoke to Anne-Marie quite a lot about it and try to feed it back into other designs, because it's now trying to change the way that things are being designed in the future, and it's looking more at a dynamic simulation for engineers, and what that'll do is reduce capital costs, but ongoing revenue costs will reduce as well if it's something that can be incorporated in design.
Because I guess, Chris, the thing is, for us as an architect, we don't get to VE the substation. You know, that's something that we don't ever have a conversation about really at the start of a project. But, you know, what I understood was this substation uplift was costing 600,000 or 700,000 to put in. And actually, you know, yes, there's resilience there. Maybe there's other loads can plug in, but this site is within the context of an existing housing estate. So it's not like another couple of hundred houses are going to hook onto this substation anytime soon. So it's a really interesting world, just that world of energy, and how actually if we produce buildings that have such a low energy demand, you're allowing more space in that grid for, you know, other needs for that energy, whether it's, you know, the AI data centers or, you know, other areas of need across the estate or the region. Which again, I guess it's really, really compelling. So yeah, an outwit of the project, but really relevant observation. I think as architects, we should be always asking those questions at the start of a project. You know, how are these things calculated? You know, if we're designing a net zero building or a passive house project, we can probably reduce that down, and we're going to work with the Passive House Trust and CIBC to build an evidence base for that, because as Chris said, there's compelling savings for the client monthly, but also compelling savings for the contractor to maybe, and also maybe not having to wait such a long time to allow an amount of load to be released for that site. I know around London at the moment, you know, there's lots of sites in development that are waiting for grid connection to get power hooked up. So yeah, a lot in that area that we want to touch on. And then this is just September 2024 was also another month where there was overheating and a heat wave in Scotland, even in Perth. Even though the external temperature average got up quite high, so I know we're saying 27.8 here, but you know, we did have days where it was well over 30 degrees for a number of hours. The overall steady state temperature across these 17 monitored classrooms stayed really, really steady. And I've used Chris's observation on this on Robert's since, but from my understanding, it was one of the coolest buildings in the whole estate through that period in terms of temperature. So I guess just the resilience of passive house for future climate change, once designed well with kind of appropriate glazing, is really compelling as well. And I'm just sat at actually one of the other sites here at Perth and Kinross Council, Perth High, that we're going to do post-occupancy monitoring on. And again, I can see the impact of, you know, glazing ratios and how, you know, that's been baked into this project as well, which is really great to see. So again, just to come back to one of these graphs, comparing the kind of UK net zero building standard, which again, I've referred to this a few times and not the Scottish one, because it refers to defined energy metrics through the different building typologies. So, you know, the energy metric for non-domestic and education school buildings is 60 kilowatt per meter square per year. We know Riverside sits well under that. And this is just demonstrating where other passive house example typologies sit alongside that as well. And then the final section, which Chris and Robert will be able to talk a bit more about then before we go to the Q&A, is the real, you know, the real journey of how this project got delivered was through how the collaboration and communication genuinely did happen across the project. And I really do believe that, you know, it was certain people who drove that with a lot of energy and passion across the project that enabled it to be the building it is today. So we have delivered and had learned lots of lessons ourselves of the last 15 years on passive house projects, and we understand that actually, you know, trying to be very clear at the start of a project around all the requirements, getting all the risks out there, and making sure the procedure when the contractor comes on board, Robertson, which was very early through the hub process for Riverside, that we have a kind of a cycle of responsibility and who informs who of issues and how much we need to test or sense check those changes or evolutions within design or site when we get there. It's just all managed and communicated well, and it's very evident when that doesn't happen on site, where we can come a cropper or things might get hidden or missed, and actually just having it all out in the open is so important. So we were very lucky there was particular characters, notably the Passive House champion, Peter McConaughey from Robertson on the project, plus the Robertson and the client teams generally, where we had a very open forum and issues were discussed and resolved as we went as much as possible. The project I haven't mentioned yet was actually more or less delivered through its design stage through COVID. So it was a very online experience, but when we actually got to site, we were able to have posters and awareness, almost like health and safety level of kind of information about passive house. You know, please, you know, make sure that you speak up if there's an issue. So you might be out in the canteen having lunch or in the smoking shed, and you're kind of passively looking at a passive house poster, just telling you about passive house and what's happening. And that just relates to any site quality requirements that you're looking for. And passive house just happens to be the methodology here. We also undertook a lot of toolbox talks. We can see here in 2020, the COVID separation was still happening in the site huts, where we were discussing good quality installation and poor quality installation in the groundwork here, for example. And then when that gets to site, just being present, being supportive. And Robertson, at this particular corner of the site, the northwest corner, they always did a sample section of insulation or taping or membrane. And when we came out, and whether we did it on a Teams call with the Passive House champion or whether we got to site, we were able to look at the quality of what was done and say, yes, that's acceptable. You know, let's crack on with the rest of the building. Again, just quite a positive relationship in relation to a kind of collaborative decision on what she was. Sorry,
Marie. No, I was just going to say there's a willingness to learn. I think that's the key thing from us is
yes.
When I went to site and from subcontractors to the contractor as well. So there's a willingness to learn, and because we had a clear lead consultant in archetype and it was new to many people, passive house, that really did you know, foster a genuine, you know, interest and a genuine, you know, collaboration in the way we were working, and that really did help, because only when you have that honest feeling when you go and speak to people, and you subcontractors then understand, okay, you know, everyone buys into that. It's not forced, and case in point was the slide you've got there, right from the outset, with, you know, changing slight tweaking designs and things with the subcontractor on site to make it the buildability better or simpler or just easier, you know, in the Scottish climate. You know, really it was a good start, you know.
And this particular corner, I mean, it was quite symbolic, really, wasn't it? Because, yeah, it took a few goes to get the insulation quality right at the beginning. But then I think within 3 weeks, all the insulation was laid, the slab was being poured, and people were quite shocked at how quick it went, you know. So this concern about program delay kind of evaporated once people were confident. And it wasn't Robertson, it was Morrison, one of the other tier ones, who reported back from another project they did, which was also Passive House, where the ground workers reported a kind of benefit to their mental health because they've, you know, again, one anecdote, one example contractor. So I'm not saying the whole industry here, of course, but the fact that they felt better about what they were doing because they could see that it was a much better, clean job than what they'd been doing before gave them a sense of pride in what they were doing. And these particular contractors with Robertson went on to, I believe, 3 other Passive House projects based on the kind of quality of the work they did on this project. So again, that kind of filtering down through the supply chain and giving confidence and pride, particularly as we're going through this huge skills gap in construction at the minute. Surely we want the next generation to come in and be doing the new quality-driven approach.
There's a clear direction and clear, you know, mandate or clear detail, you know, but equally so, yeah, talking through it on site, you could see how they as you say, they could understand it, and feeding into it as well helps as well. You know, the buildability, I think, is one of the key things that we were challenged with the steel frame.
Yes.
As it went on, you know, but because we'd got that collaboration, we'd got that trust and element that, as you said, it really did help the project.
Absolutely. So again, I've seen and heard of, you know, tier 1 contractors and others getting a bit frightened of the evidence that you have to produce for Passive House. And I have to say, and I've seen quite extraneous costs associated with this type of evidencing as well. And I think Robertson are obviously one of the first contractors doing that evidencing in Scotland, and very quickly were able to demonstrate the simplicity of doing it and the completeness of doing it at the correct times. And really, it didn't take any, you know, I think this was the most, this is the most interesting example where they went around and kind of manually put the pop-up number beside the different pop-ups on the project. But by the time they got to the wall with QR codes, you know, cataloging all the material coming in at site, simple measure tape thickness examples for proving insulation, performance and thickness, etc. It's again all alongside that golden thread of kind of quality management that we're going to be expecting on sites now going forward, isn't it? So we were really quite impressed about that. So when it came to the end and the certification side of things, it was all pre-organized in folders, all curated and ready to review. And that was really great.
And that's, I mean, that's the crux of why we did Passive House, is that quality assured design. It's ensuring that what should be getting done, Passive House or not, you know, in terms of that should be getting done anyway. You know, you should be knowing what's arriving on site, you know, checking the installation is accordance with, you know, it goes without saying, but we weren't getting it, and that's why we, you know, moved to that.
Like local authority, yeah. Sorry, I meant to ask you that earlier on, but yeah, that was one of the primary reasons, wasn't it, that you sought this out as an alternative?
Yeah.
So just, I'm aware we've a couple of slides left and we're nearly at the end of the slot. Another really interesting collaboration was with Heriot-Watt University, who lent us their robot dog, who I think walked around sites. It wasn't every day, was it? It was every couple of days. Who was very, very lifelike and quite scary, actually, when we were on site visits with them. But phenomenal photographic record and a great piece of kind of research to sit alongside the project. And then, yes, the clash detection and the kind of live model review of what's happening on site. Interestingly, I still think there's going to be elements where things don't quite match our 1:1 perfect Revit model, but you know, we're able to manage that much better with the documentation, I think, from these types of projects. Just a little bit of contractor insight then, because Robertson aren't on the call, but Robert or Chris, please jump in. So the overall project cost, I understand from Hub, came in at just 2% over budget. And what I understand from the client is that there was a 1% of that was contingency anyway. So, you know, again, we hear things about Passive House being 15-20% extra. And this project was also procured through the Ukraine global and other kind of unrest that was happening across the world, the significant market volatility that happened, as well as COVID. And yes, the programme officially overall was only delayed 4 weeks by delivering Passive House. So again,
on programme, again, it's getting it right.
Yes.
That's the case, and giving the contractor time to get it right. And again, you know, going back to that, realizing that is, you know, you don't want to take it on when it's not ready. You know, as a client, we sort of shoot ourselves in the foot. You know, when we don't need to, we can give that extra space, and that's where you've seen the program going on. And yeah.
So there was, yes, sorry, Robert, there's this bit of time built in where there was an understanding that there'd be air tests, and there was other areas that for a quality point of view that you did want to give the contractor time for, but overall from that period on, I think we were looking at about 4 weeks only. And then defects, I mean, I think there's been a servicing of a hot water heater and a couple of other things, but in terms of any major defects, I think, Robert, have been impressed so far that there hasn't been, because there's usually quite major defects, or has been historically, hasn't there?
Yeah. I mean, me and my boss keep on saying it's the first school in memory, living memory, which hasn't had a leaking roof. A new school,
which is phenomenal.
In the first 6 months of, and that's still not leaking. So you know, yeah, it's obviously a working school. It gets used hard, but no major defects, and we had a good post occupancy review with Chris being involved, looking at all, you know, the equipment, the MVHRs and things like that. There's lots of that, but no, it's been well received, and it's worked hard.
I just think, I know, you know, when architects were on one side of the contract, but really, you know, the fact that it's not just this local authority, but several others who have also said actually a lot of the new build capital projects have had significant defects. Just, you know, really, it, you know, comes back to us as well to make sure we're trying to understand what better quality means and support the contractor, have the right drawings, have the right kind of site visits, have that collaborative relationship to make sure the quality gets delivered, rather than presuming a defect is going to occur, and you know, nobody wants that today.
Yeah, the more design up front. And we could talk for an hour about that, but that's something that drew us to Passive House, as I said, to have a quality assured design, a design that was before CDP, and you know, and had that independent overview, I suppose.
We're just coming to the end, and I know Chris has been waiting patiently to tell you all the exciting energy stuff on the project. So I have 2 slides on that. I have one slide where it's just, Chris, your kind of overarching reflection on the project. So please don't feel like you have to read out the slide necessarily. And then the next slide is going to be just about what you did to optimize the project, you know, after we all left and you guys are managing. So it might just be that you kind of introduce what you do for the local authority first.
Yeah, so thank you, Anne-Marie. I'm the lead energy officer at Perth Kinross Council. So on these projects, the capital projects, we are part of the project team. We'll write the specifications or associated annexes and work the way through the con. But predominantly, we kind of take the building on at the end, and we work with the teams when we're doing BPE. Most projects we'll do our own, but with this project, it was quite a collaborative, what Anne-Marie said. So we had working groups for the first fortnight, which had ourselves, the main contractor, subcontractors, also had the consultant, and it also had archetype as well. And it generally was going back, seeing how the building was operating, because like any building, it's all great as soon as you start adding people to it, that's when you get the problem. So that's when it was those periods of when we're analysing. We put things like soak tests into these buildings, so it's making sure that the whole building runs efficiently within a set period of time. It was a week, no problems, feeding that back in. And then when people start to get at, that's when you really start to see the difference in how a building's going to operate, and eventually going through the seasons as well. So you've got your 4 different seasons that's coming into. So very interesting how it worked. So yeah, some of the things that we picked up is we develop, and we've obviously invested quite heavily into BMS controls. One of the big things with Passive House is there's a lot of packaged units that are there, but what we try to do is integrate. You can integrate packaged units and control and pull the data back through the BMS point, so we can make them work efficiently as possible. It was very important for us. We had our subcontractors involved who were on the project, who were really great controls contractors who tried to understand the equipment, worked with everybody, trying to learn experience. That was a big push we kind of had, try and get it working as efficiently as possible. And those working groups were essential to kind of that. The BPE was something that we were trying to push now, not just on our major projects, but because of the success we've had in Riverside on even our smaller projects in-house. So my team is kind of looking at these in smaller scales and trying to push it because it has been so good. Getting the feedback from the school as well, but getting feedback from the actual design team and trying to make improvements as you go. And then obviously trying to make improvements for future projects. And the big thing with this, and obviously Anne-Marie, we talked about the kind of PV integration. You obviously want to put on-site generation in here. The big thing that we probably looked at with PVs, you probably didn't need them for this job. It probably would have passed without them. And that's probably the next step when you're looking at modelling and actually understanding how energy is going to be used in this building and how beneficial they are. We probably use about 7 to 8% of the energy is generated. So even then, it's not a massive array, but you've still got a percentage of it that you're not going to be using in site, and predominantly through the summer when the school's not operating. So these sort of things are really interesting, probably things we want to build into future projects that we're working with. And Anne-Marie's been great trying to feed that back in and looking at solutions going forward. So the design software, the PHPP that architect use and architect we use for passive house buildings, we've also kind of integrated with RIAS VE that we use in the energy side, and instead of one telling the other what to do, they've kind of been used in tandem just to find the best solution, which has been really good. And that, I think, Anne-Marie, you're probably right, they've supported each other really well, because you're looking at where one kind of breaks down, the other can help the other one, and it kind of feeds back into a design team who's all really keen to work and find a better solution rather than pointing fingers of who's wrong. And that's been one of the key things for this. We've talked about the standing charges. That's something we've looked at, and it's something that now that we've managed to reduce them, we can feed that back into other future projects. The one thing, the interesting one, was probably the ventilation, the heating as well. We changed the way that the ventilation works. So one of the big things about passive house is that air quality that you're looking within a building, and the operation of your MVHR to recirculate is very, very important. Understanding how the building's being used is also important for us. So we found out, because the building's being used to let kids in and out of the building, there was doors being left open, and what that was actually doing was cooling down the building. And because you're using the heat that's within the building to reuse the feedback in new cleaner air. What was actually doing is it was pulling out colder air from the classrooms and pushing in colder air. And the reason was just because they were leaving the doors open. So we just made some alterations, very simple alterations. We actually staggered that the ventilation would come on an hour after the kids were in. We monitored the CO2 levels to make sure they didn't exceed the parameters they were in, and they didn't. Manage to get a bigger heat gain within the building, and then you're still getting the ventilation rates and the air quality in the classrooms, which was really, really good. The air source heat pumps were designed to 45 degrees. So simple people who don't know heat pumps, the lesser temperature you can get and the warmer it is outside, the more efficient it's going to be. So we actually lowered that down to 40 degrees and still make the same set points. Our temperatures in the mornings are optimized temperatures, and also our temperatures are high limit during the day. Had no impact. We changed it without telling anybody, and nobody noticed. But again, the system works more efficiently. So all these kind of changes we've done over the first year of operation, and then going into the second, just making these little tinkers just to make sure the building is still going to be operating, because the main thing is obviously for the end user and not see any difference and for it to be comfortable for them. But us just trying to find better ways so the equipment can work more efficiently, expand its lifespan, and obviously reduce the consumption as well, which is we'll continue to do on Riverside. We obviously, like we said, we've got to report it for the LEAP funding, and I've got quite a good team that will go and continue to analyse it, and we'll be doing further analysis on the site as well.
Thank you, Chris. And yeah, I think it's just really, really great when you have a really informed client who is very passionate about continuing to monitor and oversee those buildings and take that, I guess, kind of collaborative responsibility forward, which, really does support the continued performance. So very quickly, we're just at the end. Sorry for Zoe and the team. So other insight gained, as well as some of those technical aspects from the client. So having that early design team appointment, I think, was really formative. The fact that we were wearing both hats as the kind of energy consultant and architect, I think, was really beneficial to kind of keep things quite efficient and informed across the teams. A lot of knowledge and upskilling and knowledge sharing, happened on the project, and again, kind of set us up quite well to roll that out on other projects, which is great. And also we see Robertson delivering that on several other projects, as well as Perth and Kinross having the confidence to demand more on their project briefs as well. The communication and collaboration hopefully is evident from the presentation today. And we didn't get quite into it, but that Passive House Trust Steel Guidance working paper, I urge you to have a look at it. We'll give you a bit more information technically on that delivery angle for sequencing. because, you know, steel frame isn't impossible, but it is that little bit more challenging. So we do need to take a little bit of extra care as designers when we're setting that out at the very beginning. And, you know, just to wrap up, you know, the building really is a catalyst. It's very, very popular. It really improves that kind of civic presence in that particular area of North Muirton, and that kind of community investment, I think, is going to pay dividends, particularly with those two school communities coming together. And there's kind of natural interest. The children have been watching the school develop, and there's been school tours with the kids as the building was coming close to completion. So they're very proud of the fact that it's a sustainable low energy school. And the project has had great impact, which is represented by the RIAS Awards we've been received this year, which was really humbling, as well as other publications across industry, and continuing on into the Passivhaus Trust work with Tier 1 contractors in Scotland about general quality and delivery of high performing buildings. You know, how do we execute that? How do we ensure we can kind of roll that out to be a bit more mainstream? So please do, some of these are available online, and the Passivhaus Trust paper hopefully will be due out in 2026, which is when we understand the building regulations, hopefully allow us to have passive house as an equivalent way of achieving our energy requirements in Scotland. So yes, that's all from me. Thank you very much, and we can take some questions if we need.
That's great. Thank you so much, everybody, for your presentation. That's really interesting, and appreciate you taking the time to do that. Sorry to keep everybody back. If we can just have a couple of minutes for questions. If you don't mind, if I just kick off myself, I was interested at the beginning when you showed us some sort of sketches or early designs, block plans of different locations for the building. I was curious as to the final location and orientation and design. Was that primarily driven by passive house design requirements in terms of overshading and orientation? And is there, following from that, is there scope for extension if there was a population growth, and would that affect the design? Is there possibility to do that, or would that not happen?
I think, I mean, again, Robert might be able to give the actual demographics on the extension potential, but I think there is actually already, I think, a two-stream element of redundancy built into the classrooms.
Yes.
So that's been already baked in. So for 500 pupils, I think there's 2 or 4 extra classrooms. I can't remember. I think it's 2 extra classrooms.
Yeah, 2. Yeah, I mean, it's a great site. There is additional space there for that. It was never part of the brief as well. That's one thing to say. We were going to have the possibility to extend.
I think the space is probably to that east elevation where you'd continue that wing up on the kind of side, on the side, which there is a little bit of shading impact on the north facade then in that case, but not on the south facade. So yeah, something we didn't have as part of the brief explicitly in relation.
It's a fantastic site. I mean, there's a lot been written in the past years about schools going on small sites. This is not one of these, and it shows you, you know, how important. I think it should be added how important the site is to the success of the building. Playgrounds are important. Space is important. Approaches are important, and it's rightly balanced. It's to the right side. It does make the civic presence. It ties into the existing area at the front. So no, it's we're very.
I think
happy
from a sequencing point of view as well, Robert, wasn't it? You know, the desire by the council to retain that play space while the building was being built for this.
Yeah. Not forgetting the fact it's a tandem build. We had to keep the existing school up and running and operationally, safe. So, it worked out perfectly, I think. But no plans to expand anytime soon.
Right, it's interesting to hear that you've kind of already built that in at the beginning. So, with having the additional space already there. So, and I'll come on to a question because I know we are short time. Marcos is asking a question which you probably get this sort of question quite a lot when it comes to upfront carbon versus in-use carbon, passive house design. I do know you you were looking to maybe have CLT more, and you had to switch to steel. Maybe it was costs, but I'm sure you can go into it a bit more. But so Marcus is asking, in the context of using steel structure in lieu of timber, how do you assess embodied carbon alongside passive house, especially given the recent 2023 revision of the DFE output spec that sets targets for embodied carbon?
Yeah, I mean, I think it's just really important to make sure we define what embodied, so, you know, people misrepresent what they mean by different types of embodied carbon. You know, is it the upfront carbon that's associated with module A, or is it the embodied carbon that's associated with modules A to C? And when we have to consider end of life of these products, we're limited by the fact that we have to consider that if steel and timber or CLT ends up in landfill, timber will emit methane. And whilst we love timber frame and CLT, would have much rather it was a CLT or timber frame building from an upfront emissions perspective. Overall, when we look at whole life carbon, it becomes a little bit more nuanced. So, you know, we were asked this before, and very much I would not have been a steel frame fan in relation to come on my kind of initial years in architecture. But there's potential within the steel industry to create, you know, the reuse potential for steel, not so much the green, because, you know, there's a lot of greenwashing of steel frame going out there. And I think there's a really good structural firm in London who do an awful lot of publicity on this called Hain Tillett, who do a lot of reuse and have developed a reuse steel market with a number of demolition providers essentially that are also seeing that market and stockpiling sites around London, the M25, for reuse of that material. Coming back to your question, passive house doesn't inhibit you reaching any of those targets. If anything, it should really help you. And, you know, there's a concern about having additional insulation, but I think you just have to be mindful of where you draw the boundary. And yes, this kind of embodied carbon is becoming more impactful as we decarbonize the grid. But I think, you know, we can't just suppose that the grid is at a zero carbon factor right now, or suppose that we shouldn't be driving down energy demand. And I think, you know, it's worth it to do that, to reduce consumption, to reduce that overall operational footprint where we can. And, you know, the much wider issues around whole life carbon are the material flows across the world and how we're in absolutely no control of that. And that's where the real harm is done from a material selection point of view. And unfortunately, in a whole life carbon assessment or in a metric about whole life carbon defined by whether it's the DFE or others, it doesn't really allow you to consider those properly. So I guess my approach would be try and reduce the upfront emissions first of your materials as much as you can. So if you can choose timber frame, brilliant. But we know the reuse of steel and moving away from green steel is going to become a more common thing over the next few years. And I really want to get more involved in that. I think especially in non-domestic buildings, there's real potential there. And there's a process where reused steel can be re-warranted, sold on. That process already exists. There's EU standards for it. We just need to be more aware of it as architects and demand that we can consider that from our design teams. So yeah, it's a very nuanced question, because actually the more I learn about carbon myself, the more I realize even our standards and our metrics and what we understand about carbon as architects is only a drop in the ocean about what's really going on globally. And it's, I think, you know, yeah, it's another hour for another day, I think, for sure.
It's also the question about what's deliverable across,
yes, of course,
in the construction by Robertson's and
very good point.
the other big contractors.
Familiarity with the supply chain.
Yeah, that's the key. You know, you've got a limited supply chain to do CLT and glulam. So, you know,
we do, and that market was very isolated at the time, where, you know, actually Kinross wanted a CLT school. You know, everyone was supportive of a CLT. And the market just wasn't really available for us. But, you know, since then we got Maybury Primary School through as a timber frame glulam solution. And that tide is turning, and there's some publishing we'll do later on this year around safe timber frame schools. We've been working with organisations across the UK to kind of de-risk the fear around building in timber frame, especially in education. But, you know, you're absolutely right. And this is the first time Passive House was in this market. We wanted the supply chain and the contractor to feel familiar and comfortable with his supply chain to deliver the right quality. And that was also a driver in relation to pursuing the steel frame solution.
Okay, great. Thanks for that answer. And very quickly, before we round up, this might be one for you, Chris. I noticed your figures as well, that you managed to reduce your carbon consumption quite substantially after the first year. So there was obviously a bit of a learning curve there. Do you find it, or in hindsight, when it's a passive house design like that, do you have to be very careful about educating your users? I mean, is it just the facilities manager or the janitor, or do all the occupants have to be educated to some degree about how to use the building? Or is it fairly straight? They're kind of ignorant of that and they just get on and use it as they would a normal school.
It's probably easier. It's quite simple in the sense that the heating system ourselves, we control it. The air handling units and the MVHRs is all controlled. The point of use is all there. So the energy side of it it's mainly controlled centrally. What they really just are to turn up and report if there's any issues, to be honest. The only issue we probably had right at the start was the understanding and the education about Passive House itself. I think they thought that it was going to be an air-conditioned building that was going to be set at a temperature, and that wasn't the case. And there was probably just a little bit of understanding, and you still open your windows when it's over, and you still want to try and use natural light and maximise the use of any sort of energy for MVHR. If you feel like you need fresh air, you can still open the windows. So that probably right at the start of the project was just more of a learning curve about what they were expected and their expectations of Passive House. I think they thought it was going to be, you're going into an office that's got an air conditioning unit, you set the temperature and that's what you're getting. That wasn't the case. But that very early, they kind of got that, and they understood how they're to be used in the buildings. It wasn't like, do not open those windows. I think at first that's maybe what we thought it was. The windows are there. They've got the option to open them. Please use them. And that was used very, very well. The system is, we've got a lot of data pulled back through for our own monitoring and trying to improve other designs, but the actual systems themselves are quite simplistic. The packaged units, like MVHR units, no matter what anybody tells you, when something's got its own controls, it's not simple, because there's a lot of like brains and information and data software in the back of it. But the actual operation for the end users, it's probably very, very simple for them. They don't really have to, and they've still got TRVs in the radiator, so if they are too warm, they can turn them up and down. So it's very, very simple for them, and probably not much change at all.
Yeah, I guess the clue's in the name. It's passive, so it's not complicated for users.
Yeah.
So yeah, great. Well, I'm sorry, Anne. Yeah.
No, sorry, yeah, just to wrap up. I think, yeah, you really do want you want the teachers to get on with the teaching and not worry so much about that kind of control of their comfort, but they can control their comfort if they need. And yeah, keeping it simple, I think, is where, yeah, there's a lot of concern that users kind of can, be in a very complicated building due to Passive House, and that's not the case.
Yeah. Okay, I think we're come to the end there. We're going to have to round up. We could probably sit and learn a lot more all afternoon, but we do appreciate you taking the time to do this presentation for our members. So thank you so much, and thank you again to our sponsors, Luths and the Survey Association, for joining us today and sponsoring the awards. That's much appreciated, and we appreciate the CPDs you run for us as well, which are great at lunchtimes. So we're going to round up there, and hopefully that has inspired some of our members, educated some, and perhaps some of our members will now be entering our awards and following in your footsteps. So thank you again. That was great.
Great, thank you.
Okay, goodbye.
Bye.
Thank you.